Welcome to day 4 of Advent of Code. I'll be using the F-star language to solve today's problem again. I wanted to throw a shout out to Jonathan Scher, who is solving Advent of Code in Terraform. I think this is really impressive. It's solved all 3 days so far. It's on gitlab.com/sharebear. Check that out. One of the problems I had yesterday, I did manage to resolve. I had trouble convincing F-star that a list literal of length 12 actually had length 12. I was close to getting it right. I had previously done assert norm with length of the whole literal in there, and that didn't work. It wasn't able to, I think, tell that the literal was the same as the one I was returning, but this works. We can say let x equals the literal we care about, assert norm, so that uses the normalizer. It basically does symbolic evaluation to see, yes, that's true. And then when we return x, it gets the type attached to it that, hey, this is a list and every element of the list is less than a natural number less than 12, and the length is exactly 12. So this is the short version of what I had. I pasted in a page worth and a half worth of code to solve yesterday. Oh, I'm not sharing. Good thing I checked. All right. Yeah, so this is what I was talking about, that we want to have a list literal of length 12. We want to know that it has length 12 to use it in other things that require a list of a particular length. And so this is the way I found to go about it that's short, that we put the literal in a variable, we assert the length of that variable is 12, and then when we return the variable, it says, oh, I calculated the length of that. I can put that in the refinement type. I don't know whether I wanted to show, well, we got 30 seconds left. I put up a link. I'm not sure I was screen sharing. Somebody is doing Advent of Code in Terraform. I think that's very cool. I'm using F-star, which is a dependently typed functional language. And I joked in my tweet earlier that this uses the Curry-Howard isomorphism or correspondence, that functions are actually proofs. So you can view this as a function that returns, a particular variable, but also a proof that this type exists, that there actually is some list with this property. That if I'd said, hey, give me a list of natural numbers with n less than -1, then it would never type check. There is no such list. So it's not a very sophisticated proof, but it's a proof. And we're up. So, giant squid. Okay, so we get a list of numbers and a random set of boards. Okay, the first 5 numbers. Okay, so we're looking for a board that has a row or column, but not, I guess, a diagonal. Okay, and we have to sum up all unmarked numbers on that board. Okay, so let's take a look at our input. It's pretty lengthy. All right. Sure, let's get started. So let's define some types for our board and some code to parse that in. Okay. So what I'm going to do is I'm actually going to copy I can remember what day it was that I defined a matrix class. There it is. All right. I'm going to need I/O. We're going to need string processing. We're going to need the all effect to do I/O. We're going to need list. So I put list twice here. Hello. I put list second here so I can just use the normal length instead of worrying about string length overloading that. Okay, and let's define a type we could just use true and false, but let's define occupied or empty. So we'll have a matrix of integers of numbers and a corresponding matrix of are they occupied or empty. I'm wondering if there's some clever way to go about this, but like, should we index where all the numbers appear so we're not laboriously looking it up each time? But I think we'll be okay. All right. Everything okay? No, I didn't type any of the names correctly. Oh, I didn't want just list, I wanted total lists. There we go. So the difference is these functions are all total functions and the others are merely, can have effects. All right, so sure, let's write our parsing code. So that's the wrong one. I think we have, well, everything's all nicely lined up. Okay, I was going to say, I think we have a string split function, but we don't actually need that. And that would be a problem because of these empty extra spaces. Okay, let's, okay. I should really write some of these ahead of time. So let's parse our comma given a string, this returns a list of all right, so let's look up what we've got in string. Do we have to convert everything to a list first? Is there a split? There is. Splits the string by the delimiters in CS. Okay. I don't know if we've got a parse int function we can use, but we just split. That's a list of just comma of s. And I believe, unfortunately, there's no good. Oops. I don't believe there's a good parse as integer function. We're gonna have to write that ourselves. I think that only exists for okay, so the more specific integer types have of string. Let me check on that. Yeah, I'm not seeing something that just returns an integer, but these bounded integer types work, and we can okay, so we'll create a lambda, a temporary function. So we'll say from x, which is a string, to star dot 2 dot of string x, which okay, we need to string dot split. List has a split too. Okay. Did I get this backwards? String t, okay. And we need to take, we need to get the normal int out of there. There's int to t. Okay. I feel like I'm missing something here. Wouldn't be the first time. Oh, dot v. All right. Oh, all right. I haven't used these machine integer types before, and it shows. This says it's should be that the int t type cast to int, but let's just do this explicitly. Um, uh, all right, that works. So we'll just use that. Yeah, I have this problem occasionally with F star where uh I think it should be able to take a list of one type to a list of a super type, and it's not happy doing so. So I keep making that mistake. I think that's what happened there. And if we just tell it, oh, take it all the way to an integer, then it's fine. All right, so there's our parsing our first function, and now we need to parse a matrix from what are we going to take? Are we going to take 5 strings? Um, yeah, let's do that. So let's take a list a string of length 5 and return a matrix of integers that's 5 by 5. So I'm a little worried that proving all that there are 5 numbers in every row is going to be difficult. So I'm going to cheat and just fail if that's not ever not the case, which means it's no longer a pure function. It's a function with effects, and one of the effects is it throws an exception and says that I'm not working right. But I'm not real happy to be doing that. But all right, let's break this down into parse space separated numbers. Except now we've got this problem with splits. So All right, let's say the string is, okay, here we can address this both places. So we say that the string length of S is at least it should be 5, 2, 4, 6, 8, 10, 14. And so we want to map our parser over. I'm running into the list literal length problem again. What I'd like to say is we get a list of integers of length 5. All right, so let's make use of our hard-won knowledge from yesterday, and let's create a couple of list literals. So our first one will be it will be the number, it'll be 0 to 4. Oh, God, we confused it. Okay, good. So we want to map our integer parsing over a list of substrings. So we'll take the index and we'll take substring of S starting at indexed index times 2 and going up to times 3 and going up to, is this going to get complicated? We just go up to +2. This shouldn't be hard. Okay, we're going to parse. So that's offset 0, that's offset 3. We want to go to there. That's +2. All right. Come watch Mark do basic integer arithmetic. Oh, it's not actually a Lisp. A Lisp despite all the parentheses. All right. Okay, so this is the version of string that can throw an exception. So we want the version That's a total function. So that's sub. So we can see the restrictions on that are the index and the number of characters. Okay. It's not the end position, it's the substring length, so that got easier. Okay, and that's expected type nat got type int. Why doesn't it know? All right, let's tell it that's a nat. Will that help? All right, so what it says is I expected that substring condition to hold, and you haven't convinced me that it's true. Maybe I'm going past the boundary of the string length. All right, so what doesn't it know? So let's throw in a bunch of assertions here. All right, so it should know that I is should know I is less than 5. It doesn't know that. Interesting. Why not? Oh, because I didn't. Let's. Okay. Expected type list string got type list of string of lengths 2. Okay. All right. Let's do the same thing. So this is a string and length is 2. Sterling. All right, there we go. We just had to give it the right types in these anonymous functions. All right, so if we give it a list of strings, each of which let's just make it equal. Good. So list of strings. Each string has length 14. The list as a whole has length 5. We should get a 5 by 5 matrix, and we can make this a total function again. List as, okay, parenthesis there, there. Okay, so vector is just a list, matrix is just a list of lists, so should be good. Let's just map parse space separated numbers over our input. Hurrah! All right. Go us. All right. I've now wasted 20 minutes on simple parsing. If you're looking for fast solutions, this is the wrong Twitch stream for you. Okay. So let's finish writing our parser. We'll copy a little bit of yesterday's code to do the sort of okay, so we're going to open our file. We're going to read the first line, which is our order, the ball order for the bingo game. I don't like that name, but I can't think of a better one. So we're going to read a string. And we're going to call parse comma separated numbers on it. Okay. And we're gonna have to read a line between each of these. Is that correct? Yeah, so we might as well read a blank line before every matrix. Yeah, there's no blank line at the end, and even if there was, we could edit it out because there's actually no requirement that you just that you take the input as is. You just have to get the right answer. I hope that our parser function works with spaces. Let's check that quick. All right. Let's assert that int32 of string of space 7 equals 7. Int32 dot. What's the right function there? It is int2t. We may not. Yeah, okay, it's the problem. It's not. It's actually implemented in OCaml. Let's take a look at that a sec. So if we go into the standard library and we look at the star int32 module, that just says that uses I don't actually know OCaml So that's is there actually documentation on this? Can I run it interactively? Let me just. Yeah, that's the problem. I don't actually know. I don't actually know OCaml all that well. I learned string space 7. I don't know how to do anything, I guess. All right, let x equals int of string. Okay. Well, I was hoping not to have to write something that printed out matrices, but I might. All right, phooey. So the problem is the standard library has virtually no documentation in FStar, and I don't think there's a lot of examples. Let me see if anybody has used this. Okay, well, it works with hex numbers. That's good to know. All right. Let's just take care of this. All right. So if sub S1 equals space, then sub S1 take the second character. Otherwise, just take the whole thing. All right. Oops. All right. So we're going to read a matrix list from the file descriptor. And then we're actually going to solve the problem finally. Okay. It's a read input, and it's going to return a list of 5 by 5 matrices. All right, so we're going to read. It's awfully hard to get things done without a for loop. So the problem is that the things we can't just use the same map on this. We're going to have to use the other map that knows how to deal with impure functions. Or we can just cheat. And okay, length is 5. We want the type to match so that we can. Okay. I'm just going to unroll the loop here, I think. All right, let read 14 character line. All right. If strlen s not equal to 14, so not equal is not bang equal in f star. It's less than greater than smushed together, which Emacs helpfully turns in another character for me. Fill with oh, I need to tell it this is a function that can fail. Okay. All right, so I think we're gonna have to do some work here like we did before. What am I doing wrong here? There's the list. Oh, L is the list. Okay, that worked. Good. Can tell that there's actually 5 lines, and we read the blank line to begin with, so okay. Lines equals read 5 lines from the file descriptor. Oops, we needed our try. That's how we handle exceptions. So if you got end of file, there's nothing there. Otherwise, oops, that's not a colon. We're going to parse our number matrix from those lines and cons it into a recursive call. And because it's the ML effect, it doesn't care that that might not terminate, I think. All right, good. So sure, let's try it out. The standard library doesn't have anything nice to like print out lists, as far as I know. We could join it back into a string, I guess, but what did I read line? Okay. Okay, OCaml is complaining that we didn't use some of the variables, but that's okay. All right, now we can actually get down to solving the problem. Okay, so we're going to work our way through the list of numbers. We're going to mark them off on their cards. We're going to check the cards to see if they have 5 across or 5 down. And so we want the first winning card. So let's actually all right, so a card is a matrix, a pair of a matrix of integers that is 5 by 5 times a matrix of squares. Okay. That'll be easier to move them around. Then we're gonna, so let's write a function that takes and returns a card So it's just M, and then this is a lot easier with list comprehensions in Python. Everything's a struggle in F star. I really should be writing some library functions like repeat x 5 times and give me it. 5 copies. So we have an implicit type and one of them, and return a list of that type that has length 5. Mostly I just define everything on one line. You can use val to sort of declare a function's type. Okay. So will this just work to... those are all V's. Why is that causing it problems? Oh, the syntax is different in the let statement. I obviously have no idea what I'm doing here. Let's see if this works. It says we got a function here instead of a list. I don't know why. All right, I think I just screwed up the val statement. All right, so we want M and we want 5 copies of 5 copies of empty. Good. All right, so the first winning card, so we're going to take our list of integers, so our order, which is a list of integers, and our boards, which are a list of cards. and we're going to return a card. We're going to return an option card. It might be that no card wins. I'm sure the input is such that some card does win, but we can't prove that that's always the case. All right, so I'm just going to write out what I want to do and we'll fill it in. So, okay, so if the order is empty, then we didn't find a winner. Otherwise, it's got a head and a tail. So we're going to mark head on all the boards. And we're going to say I'm going to find a winning board. We can do better. We can say match. So if it's none, then we want to recursively go on to the next thing. So first winning card with the tail and our marked boards. And if some card, then that's the one we front return. All right, so let's write all those pieces. So we've got a number and a list of cards. And this returns a list of cards. So this is just a map. Card num. Yeah, I can write that as a amortized function. All right, so we want to find our number, and everywhere it appears, it should only be one place, but we can handle it being multiple places. Is there anything? It doesn't say one way or the other, so I don't think it's an assumption that'll hurt us. So I'm going to use the indices. All right, function the y position. X position, and we'll do something in the middle of 0 to 4. Oh, I didn't like that. 0 to 4. I've lost my faith. I will pick an appropriate type for the function, so I'm specifying it by hand. All right, so let's new mark. All right, so what we want to do is if all right, let's assign these names. So let numbers equals the first part of the card and marks equals the second part of the card. So if, what should I call this function? Value at numbers yx is equal to the number we're looking for, then we want to return a occupied, else whatever the old value was. So marks yx. Okay. And then we just return numbers and new marks. Occupied. Oh. Too many arguments. All right, which means I've got a parenthesis somewhere. Okay, I'm going to map that across that 0 to 4. Close that. Uh-oh, it's taking an awful long time. All right. All right, it doesn't believe our matrix is the right size. It says it's just a list of squares as far as I can tell. So this is also a problem I solved in the warm-up. What did I do there? I wrote a custom function. That has the right types. So it can tell that that function in isolation works. Okay, good. I call the type card. Okay. All right, so we haven't written find winner. All right, so I believe there's a list function that returns the first value that satisfies a predicate find. All right, so all right. I mean, this function becomes trivial, but that's fine. All right, so we need to find a one where the row and the column is filled in. And this would be really nice time to introduce a refined type on this bool to say that we got it right. But the type is going to be very complex. So let's split it up. Think something's going to too complex. Let's break it into two parts that are simpler. So it's either a row winner or a column winner. And if it's a row winner, we can say which row it's in. So all right, which means we can get even simpler. Okay, let's do this then. Is row this is a bool, and the bool. We've now simplified things where the type and the the type and the function are of equal complexity. So if B is true, then the markings value at second all right, maybe we should simplify this by even further. Oh no, we've already got a row. So what we need is a function that says the whole row has a particular value. And there we go. Okay. All right, this feels a little simple, silly now. Um, square, the square equals occupied. Index R in the second card. Yeah, so this feels like we maybe gone off the rails a little bit. Is there a syntax error? No, it's just unhappy. Oh, yeah, I made that mistake before. All right, so what it's saying is I expected your thing to be in range because I don't know what the length of the second element of the card is. But I don't know why it doesn't, because we told it. Seems like that's something you should know. Oh, we gave it in. They're not the same. We gave it an int. Yeah, it should be in that. All right. Much better. All right. All right. It accepted our horrific type, and we're going to make an even more horrific type. So this is going to be true if there exists some row that got the syntax wrong on that existential quantifier. It's period. Seems unhappy again. Yeah, let's. What is the syntax error? It is. Oh, all right. We need to put that in parentheses. It's just a precedence error. The existential quantifier is. Okay. Crude, but we prove that if this returns true, then there's some row that's the winner, and we don't care which one it is. So we can do the same thing for columns. If we're really clever, we could transpose and use the same functions. I don't think I'm that clever tonight. Okay, so let column vector I get that right? Nope. And again, just copy and paste programming because I'm getting tired. At yeah. We could have used map and our fancy 0 to 4 function. Oh, column. I got problems all over the place here. One of which is I can't remember which order I put things in. Okay, gotta replace C with second C. Okay. So it occurs to me that equals is an operator, is a function. So I could maybe get clever here and just change this to equals occupied. Let's see if that flies. It does not. Eq. I shouldn't be too tearing, but now I'm curious. It should be possible. This looks like a type, not a function. Okay, so what is op equals? All right, I guess it doesn't work that way. It should, but all right. So our winner, our is winner function. See, it either has a column winner or it has a row winner. All right, so all our types are small, all our functions are so almost small enough to just be silly. But that's fine. The same trick didn't work again. I wonder why not. Oh, because I used and rather than or. Okay, don't do that. Or is V. No, still unhappy. So this shouldn't work. Oh, okay. No, we asked it. We asked it to guarantee that one of those existed by just putting the type there rather than any reference to B. So those are only true if we return true. If we return false, we'd like to ensure that neither of them is true. So maybe can we make that if and only if? We can. Okay. The type is called option. Its constructor is type called getting longer and longer. Okay, good. It just wanted us to it's the same problem we're having with lists, right? We can't return a more specific refined type into the general option. We have to specify. All right. So this function should be done. So now we just need to calculate the score. So we should be able to do a fold. So one thing is we fold over our indices and we return 0 if it's been marked, and we return the value if it hasn't been marked. So function I, where did we last do this? I might as well be consistent and call it X. All right, and we need to give it I think it would be simpler to do this in 2 steps, is zero out everything and then add it. Is there a way to, is a good way to combine these? All right, our function takes, a total, which is an integer, and a total, which is an integer. All right, and if uh, the value at winning card yx equals occupied, then leave the value alone, otherwise total plus value at first. We get this right? I'm a little worried about this function now. Value at, okay. All right, so there's our function. That does everything, and we need to fold it starting with 0 over, did I get the order right? I'm not usually using fold. No, I wrote it as fold right. All right. So we want to do this over 0 to 4, starting at 0, and then do the same thing on the outside range. It'd be really nice to be able to assign a type to this to guarantee that we got all this right. At least prove a lemma about it. All right, well, let's try it out. I think all the pieces are here now. So First winning card. Order. Cards. In. All right, we need to check that we actually found one. Match W with none. Some winner, then I want to print score. Calculate score in print. Okay, we need something I didn't pull in. Score. It's called printf. It's only got the string printf version. All right. Slowly type checking everything we did again. Oh, we didn't transform the cards into their blank state. To empty card. Okay. All right. Well, we know it'll run. Oops. Will we get? Oh, and we had. I forgot a step though. It asked us to multiply by the last number, which we forgot to get out. Well, crud. We can fix this. So we want to return int pair all right, let's try that. All right, let's see what we've got. Nope. I messed up somewhere. The thing about learning a new language is you feel dumber. Ran into problems last night too. right, let me make sure I'm not misunderstanding the rules. All right, let's try the example input. Oop, oop. Well, 0 is not a very good thing to see. This looks like it's backwards to me. No, no, that's it. That's not it. Okay, all right. Something's funky here. We're not adding T. We're not doing the fold. So this integer, this one gave us a number, and we just didn't do anything with it. Okay. So how could we write a type that expresses that? It's a fairly complex behavior. I think I said I would like a type that guarantees that we got it right, because it's a little complicated. In fact, I got it wrong. So let's try again. All right. So our board score is correct, but our number. Okay, so we thought it was 10, so we've got an off by 1 error. Hmm. Okay. It's not obvious how 10 would complete the square if we're doing anything right. So I'm wondering if our mark function is wrong. Again, it's fairly complex to describe because we don't have a lot of primitives for working with matrices. I was hoping it was something obvious here, like we hadn't using the wrong value. This backwards. All right, let's try to prove it with a lemma. Guess I don't see how messing that up on this example. All right, I guess what I'm tempted to do is just dump out every card. I wish we could diagnose this in a more sensible fashion, but I'm not seeing any obvious way to grapple at these. By it's got to be that one of these functions is wrong, but there are a lot of them, and they're all kind of hard to write types for. I guess the one I have least confidence in is value, because Did I switch the indexes? But no, those look great. That's the other index from row. Okay. Um, all right. Let print cards C card. Is that what I want to do? All right, let's look at sprintf for a second. What is the thing for bool? %b. All right, I'm gonna map that over. Oh no, that doesn't work. Phooey. Oh, we have to start over. Okay, so let square. Q with It's complaining that I'm giving it a list of units. All right, we'll fix that. All right, let's move that. Let's move this down so we can use that function. All right, so right here, we want to print print card. That is kind of silly. Okay. All right. First number is 7, 7, 7. Looks good. Okay, that. Okay, so there's 10. So what was wrong here? We saw this row, but we didn't recognize it. Okay, so that I think tells us where to look. All right, that's true. I'm really puzzled. Okay, let's try again. So let's. Is row winner I is row winner I on the card? What did we do? Yeah, there we go. Oops. I wonder if we're not finding the first winner. If we're only finding if the last card wins. Okay, yeah, our function's correct there. So it's got to be in find winner. Yeah, it says why should there be that delay then? So I misinterpreted what the find function did. Looks right to me. No, this doesn't look right. Oh no, that's our number. We found. All right, let's really need that. Wow, I really don't know what I did wrong here. Okay, so it says it's a winner, and yet we delay. Uh, there it is. Okay. Yeah, we're running the check on the input. Okay, that's our off by one. So we could maybe write a type that says it's the very first time we the type that would have helped us is saying, this is the first time that is winner is called. So let's strip that out for now. We might need again and try the real. Well, it's a bigger number. All right. Figure out which board will win last and choose that one. All right. Hmm. All right, I'm gonna copy this just in case we do end up making substantial edits. All right, so that okay. So if um, okay, so it's a little tricky with the way we wrote it here because we need to pull out the last card, the last board, which is easy, and then continue playing it until it wins. So I'd like to do that without major surgery. Okay. Uh, index 0 marked boards. So if they've all won and there was only one board before, then that's our guy. So marked boards, comma, head. Otherwise, if there was a tie, which shouldn't happen, there's no winners. Else, last winning card. Else, but we only need the non-winners. Okay, let's do the example. Yeah, I would have liked to use more types, but I couldn't think of a way to make types like All right. So this isn't so good. Okay, we filtered out the winners. Uh, what is Boolean negation? Let me look at the symbol reference. Tilde. Oh no, that's logical, not Boolean. I don't think it lists. Okay, I'm gonna have to edit the wiki because it actually doesn't have the Boolean operators on here at all. Well, shoot. It doesn't look like they have one. It's op equality, disequality, and it seems like a strange omission. Op negation. Does that work? No. I'm stuck because I don't know what logical not is. What Boolean not is. All right. Oh, there it was. There it was. All right. I don't know what symbol that is if it's not minus. Oh, it must be exclamation point then. No, because negate exclamation point is Is this an OCaml thing? Can I look it up on OCaml? No, that's just an F star thing. All right. It should be. Okay. It's not a symbol. It's op negation. All right. Oops. Where's my window? All right. 148 times 13. Okay. Looks good. All right. Well, let's see what it thinks. Hurrah! We did it. Okay. Yeah, I didn't really run into a lot of frustration with F star. It was just my own problems this time. Although it would be nice if I could have written a type here that was easy to prove and would have found my bug. So I might try that tomorrow. And if so, I'll report in the next live stream. But I think we're done for tonight. So thanks for hanging out with me. And I will commit this source code shortly. Take care.